Right, morning guys. Can you all comment your names? Most of you have already. Um, I'll start doing the register, and then you guys are going to try this question to start with, which leads on from what we did last time on geometric series. So, there's the equation you need. So I'm going to give you guys 6 minutes to do that one. Can you type your names? I'll do the register while you do this, and then we'll come back in 6 minutes and go for it. So timer starts now. Right, I haven't had any. Spoke too soon. Yeah, Lucy's just sent me an answer now. Cool. Right, make sure the rest of you are all posting answers as well. Just wait for this to load. Oh, okay. So a card depreciates in value by 15% a year. What that means is that R is going to be so it's losing 15%. So its value is going to be R is going to be 0.85. Okay, every year it's 85% of what it was the year before. The third year, so the third term, is 11054.25. Actually, we might need to be a bit careful about this one. So I'm going to do my table. I'm going to say term, year. Right, so if we start off the initial value, so term 1, how many years have passed after one term? No years. That's just new. It's this new. It's this value. After 1 year will be our second term. 2 years will be our third term. 3 years will be our fourth term. So we really need this table just so we can kind of pair up what year is what term. Okay, so we know after 3 years. So we know the fourth term. We know U4. Is going to be 11054.25. And we're trying to find out what the initial price is, what U is. So if I set up the equation, remember UN equals A times R to the n minus 1. So we're going to get 11054.25 is A times by 0.85 to the power n minus 1. So the U4 is going to be 4 take 1, which is going to be 3 on the top there. So if I get my calculator, cube 0.85, and then divide 11054.25 divided by answer, gives me A. The new price was 18,000. Alright, let's have a look and see what. I think Lucy was the only one who's. No, a couple. Lucy and Louis. Lucy, yep, spot on. You haven't actually used the formula though. I would try and use the formula and do that table for years and months and years and terms. And Louis, you've used the formula, but you've got your years and your terms mixed up. So always do a table. If it ever starts talking about real life modelling and years and such, kind of a table linking your term and your years. So yeah, Lucy, good, but try and use the equation and the table. Louis, use the equation right, but you've got your n was wrong. Okay. When will the car's value first be less than 5,000? Okay. So actually, let's keep that table. I think that's going to be useful in this one as well. And probably want to keep that value of A as well. Just 2 seconds till this loads again. Okay, so A was 18,000. So we want to find when is the value first less than 5,000. So we want to find when is UN less than 5,000. So I'm going to set up an inequality. As it says in the hint, use your answer pi to write an inequality. So remember, UN is A, so 18,000 times R 0.85 to the n minus 1. We want this to be less than 5,000. Okay, so I can divide each side by 18,000. Which gives me 0.85 the n minus 1 is less than 5/18. Now to solve this I need to use logs. I'm going to log both sides of the equation. Use the power rule to get n minus 1 down the front. Let's go back up to the top, get rid of all the workings now. If you guys need these, just pause and rewind and they'll still be there. So use logs, took log of both sides, use the power rule. And now I want to divide by log of 0.85. Now the problem is, remember, if you divide by negative of an inequality, you need to swap the sign over. Quick sketch of log. Log looks like this, remember? Asymptote, there's 1. Log of 0.85 is going to be about here. So log of 0.85 is negative. If I'm dividing both sides by negative, I need to switch that sign around. So you've got to check that and you've got to be very careful with that. Log of anything less than 1 is a negative. So we get n minus 1 is now greater than log of 5/18 over log 0.85. So we can see I've flipped the inequality round because I've divided by negative. This thing here is negative. Be careful with that. So I should be able to just type this into the calculator, add 1 and find n. So we get n minus 1, 7.88, so n equals 8.88. Am I done? Is that the answer? Quick comment, I'll give you guys a minute to think about it. Is that finished? Is the question done? So 2 minutes to have to think. I'd like you all to post an answer as well. Right, so it's a bit tricky this. Louis, you were close to getting that. So we've got 8.88. That isn't a when though, that's a term. So if we look back at our table, How do the terms and the years link together? Well, term 3 was year 2. Term 4 was year 3. So term 8.88 is going to be year 7.88. So there's a few different things you could say here. So I'm going to write here year equals 7.88. So we could say it's during the 7th year. Say towards the end of the 7th year. You could work out when if you wanted, or you could say it's after 8 years. So I think I'd go for during the 8th year, during the 7th year. So me would be the kind of way of doing it. If you're rounding up, you might want to say round to 9. Say that would be then the 8th year. Say after 8 years. There's a couple of ways you can word it. As long as you mass backs it up, you'll be okay though. It's a bit of a vague question. Does that make sense to everybody why it's during the 7th year? So always draw this table. Whenever it's a modelling question, draw a table so you know how you're linking term and year. Right, we're going to move on and try another one of these. So again, use your tables for this one. I'll give you guys 6 minutes, I think, for this one. We'll see how we get on. Just be careful with this. Comment if you need help. And please send me your answers as well. So 6 minutes starts now. Right, I haven't had any replies yet, so I'm going to give you guys a bit longer. Make sure you're all in teams. How only like 6 or 7 of you are. Yeah, I might redo the register in a minute if because I can't see some of you. So make sure you're commenting. Make sure you're giving me answers, and make sure you're logged into the Teams chat. I'll send out one more set of invites. And give you guys a few more minutes to do this question. Make sure you're answering though. Okay. Yeah, that's fine. It's in the video, Louis. That's fine. Still got no answers, guys. I don't want to be doing all these for you as examples. Yeah, I'm just gonna keep waiting because no one's asking for help and no one's doing the questions. So there we go. Thank you, Harry. Good. Someone's done it. Right. Harry says I'm not entirely sure as well. If you're not sure, ask. Otherwise, I'm just sat here doing nothing for 5 minutes. So please make sure, guys, you're pretend that you're in class, and if you get stuck, instead of putting your hand up, comment if and if you've done it, send a photo. But right, we'll go through this one. We might try a few more of these. They are tricky. So the saving scheme is offering a rate of interest of 3.5%. That means the R 1.035. So every year you get what you had already with an extra 0.35%. So the total percent you get each year, 1.035. Okay, so Alan wants to save up 20,000. He works so he can afford to save 500 every year, which he deposits on the 1st of January. Cool. Right, so term year. Right, so Alan's going to go put in £500 at the bank. That's going to be so first term is going to be 0 years. Okay, and we can write down the number as well. So let's put pound sign there too. So we do the first few of these and it comes nice and easy. 500. Okay. Oh, this is quite tricky actually. Maybe I've been a bit harsh on you guys. This is a pretty brutal question. All right, second term. It's going to be after 1 year. And how much is in the bank now? So he's got the interest is applied to that amount. So we're going to get 500 times 1.05, 1.035, plus he's going to put in another 500. All right, so another year passes, term 3, year 2. We now times all of that by 1.035. And then we add 500 because he adds in another 500. And this is going to progress each time. I'm going to run out of space. So it's going to continue like this. And you might say, well, that doesn't look like a geometric series to me. So what we're going to do, we're going to take just that bottom row. We're going to get rid of all the rest of this. And I'm going to expand this. So we're going to get, and I might do this in terms of A and R. So our first term was 500. So let's change all the 500 I'm going to say is A. And all the R's I'm going to say is 1.035. So we've got AR plus A times by R plus A times R plus A. That's the same thing, just turning it into A's and R instead. Alright, now let's kind of expand this. So if we expand from the center working our way out, we're going to get AR times R, which is AR squared, plus A times R, which is AR. Cool. Plus A. Times all this by R, so that's going to give us AR cubed, AR squared, and AR, and lastly, plus A. So that was term 4, which was year 3. And we can see that that is a geometric series. The only difference is every time it's going to be the sum of a geometric series. So lost my train of thought there. So So if our fourth term, basically I could factorize out a from this. So if I take out a, we get r plus, sorry, don't even talk, we get 1 plus r plus r squared plus r cubed plus r to the 4, etc., etc., etc. Which definitely is a geometric series. So all this stuff here, that's our geometric series. So, I wish I hadn't rubbed all this out. Where did we get up to? Did we get up to? I'm just going to rewind and see where I got to there. Yes, Wells goes up to r cubed. So you can see for our fourth term, we have 4 terms in this equation. So that's all fine. So the geometric series actually isn't what we said it was earlier. The geometric series is, our first term is 1. Maybe I shouldn't have used a there. Maybe if instead of a I put back in 500. And then r is going to be 1.035. And the whole series is going to be times by 500. So if I want to kind of sort this out then, we want to try and save up to 20,000. So 20,000 equals the sum of the geometric series. So that's a 1 minus r to the n over 1 minus r. The only difference is our series, which is this bit, is being times by 500. So I'm going to say 20,000 is 500 times 1 minus r was 1.035 to the power n over 1 minus 1.035. And we're timesing it by 500 because our series has been times by 500 as well. So then, to work this out, I can divide both sides by 500 to get 40. To get this. Times that by 1 minus 1.035 to get minus 1.4 is 1 minus 1.035 n. If I rearrange this, I can add 1.035 to one side. I can then add 1.4 to the other side to get 2.4 there. I can then log everything here to get n log 1.035 is log 2.4. Then we can work it out. So log of 2.4 divided by log of 1.035 gives me n is 25.44. So n is 25.44. I've left a bit of the table up here. So we said n is 4, year is 3. So if n is 25, the year is going to be 24.44. How many years? That's going to be 24.44 years. So how many years will it be before he's saved up his 20,000? So I'm going to say it's during 24th year, or if you like, after 25 full years. Right, that's a little confusing because basically, if I ever come up with a sequence or series question that I'm finding difficult, I'll write out the table. Then I'll write out the first few terms so I can see if there's any patterns I can spot. Right, we're going to try a few more of these. I think I was going to move on there, but I think let's try a couple more. 2 seconds. I was just going to bring up the questions now. So hang on right there. Alright, sorry there, guys. That took me a little while to find. So we're going to try this massive one. It looks kind of scary, but it's not. This one shouldn't be too bad. So read through the question, work out what the first term is, work out what the ratio is. If you have to write out a few terms to check that, do that. And write out table linking term and year. Use logs. Part D and Part E get a bit trickier, but A, B, and C should be okay. So it's going to take a while. This one was 4, 7, 8, 9, 10, 11 minutes. 11 marks, 11 minutes. I'll give you guys 12 minutes because it will take a while to take your photos and upload your answers. Make sure you comment if you get stuck, but 11 minutes is going to start now. Right, I'm going to assume you guys need a little bit longer. If you need any help with later bits, do ask. As a hint, then A and B and C are all about sum. No, A, B, and C are all about the nth term, and then D is about the sum. So maybe that helps a bit. A couple more minutes then on the clock. Right, still no answers, and no one's asking for help. Come on, guys, work with me here. If you are stuck, ask for help. If you need more time, say I need more time. But please communicate a bit. I'll go through slowly part A and B. So make sure you're watching. But in future, can you please ask for help or time or some kind of communication? Because otherwise, I'm just here like, do I go through it? Do I wait? What's going to be most helpful? So give me some feedback. Right, let's wait for this to load again. Oh no, has it disappeared it? Oh, I hate this program. Give me a sec. Oh, you've got some more time now anyway. If you rewind the video, pause it for 2 minutes because I'm going to have to find that question again. That's fine. Yeah, it is a hard question. So 2 minutes starting now. I'm going to go find that question again because it's erased all the changes I made today. Right. Alright, I had a few responses. Your part D's are wrong, guys, but I'll explain why. You weren't far off. Good. Okay. So, first of all, let's do terms and years. So the adult population is, so if I do term, year, and then to make it really clear, let's put population in there as well. So term 1, beginning of 2020, the beginning of 2012. So we'll do 2012. I'm going to put a little b there for beginning, just so we remember this number is the beginning of 2012. And the population is 25,000. Okay. So the model predicts the adult population in town will increase 2% each year. So if we put in term 2, just so we've got this as a reference, term 2, 2013, beginning, is going to be 25,000 times 1.02, which is 25,500 for the second year. So we know A is going to be 25,000. R is 1.02 because we're increasing by 2%. Keep that table here for later. It might be of use. Show the predicted population at the beginning of 2014 is 26010. Okay, so we're going to use, it's going to be term 3 for this because we want the beginning of 2014. You can kind of follow the pattern there. 2012 is 1, 2013 is 2, so 2014 is going to be 3. We're going to use U3 equals 25,000 times 1.02 to the n minus 1, which is going to be to the power 2. So I put all in, 25,000 times 1.02 squared gives me 26,010. So nice and straightforward for the first part there. Okay, the model predicts after n years the population will exceed 25,000. So we want to try and find what term does it first exceed 25,000. Oh no, we don't even want to do that. We want to just find the equation for them. Cool, alright. So what I said to Lucy here is a bit difficult. They've said n is the years, whereas we normally say n is the term. So I'm going to use k for my term, n for my years, just so I don't get mixed up. And we know that the year is k plus 2011. Yeah, so now we're all sorted. We don't need to worry about years and terms. We can do this thing in terms of terms and put it back into years in a minute. So we want the population to exceed 50,000. So 50,000, we want our value to be greater than that. So this is a r to the k minus 1. Remember, I'm using k instead of n. Alright, so let's put in all of our values. So 50,000 is less than a, which is 25,000. R, which is 1.02. Instead of k minus 1, let's actually, okay, I've done something a bit more complicated here. Get rid of that little equation at the bottom. They're not asking for what year, they're asking for after how many years. So, alright, so term 1 is after 0 years, term 2 is after 1 year. So we'll say that term 1, so k, when k is 1, n is 0, so n is equal to k. It's going to be take 1. K is my term, n is my year. Year, it's k, yeah, k take 1. So in other words, k equals n plus 1. So if I put n plus 1 in here, we're going to get n plus 1 minus 1, so this just goes to the n. So that's why we get n in our equation. You got to consider those things. It's just based on our different definition of year or term. So if I divide by 25,000, I'm going to get 2 is less than 1.02 to the power n. I'm going to log both sides. Log 2 less than n log 1.02. So I used a bit of power rule in there as well. And to rearrange and solve this, we divide by log 1.02, so we get n greater log 2 over log 1.02. We're doing log of 1.02, log of, and remember log crosses at 1, so that is a positive, so that's fine, we don't need to do any sign changing in this one. And that is the thing they wanted us to show, so that's good. Okay, now it wants me to find the year. Okay, so we're going to go back to our k and n stuff. So if I find n first of all, that's going to be log 2 over log 1.02, which gives me n is greater than 35.0027, whatever the rest is. Should really be 28 there. Let's just go safe. N is greater than 35. Okay, if we go back to my kind of initial equation, what did I say initially? I said that the n is k plus 2011. So if we say the year is k plus 2011. So if we've got n is 35, wait, is that right? Yeah, okay, that's not going to make much sense. All right, so we found it's. I've made this confusing. Sorry, guys. Okay, all right. N here was my value there. Yeah, so it's after how many years? So it's after 35 years. So if I kind of look at the comparison between these two numbers, after 1 year it was 2013. Yeah, so that's an increase of what, 2012. So if I plus 2012 to that, we're going to get n is got to be, it's going to be after. Sorry, it has to be more than 2047, so it's going to be during 2047. So that it'll be during that year where the population first exceeds 50,000. Does that make sense to everybody? So I made it a little bit confusing with my using k and n there, where they've approached it slightly differently. But all it is just what's the relationship between your two numbers in the table. Okay, all right, let's just have a look through, see what you guys put for those bits. Did you all get 2047? No, Chloe's got 2046. Nula's got 2046. Harry 20. You guys have all got 2046. Yeah. George's got 2047. Lucy's got 2047. Yeah, it is 2047. So just be careful with your linking them up. I think you guys used, a bad link between your what n was and what the year was. So be really careful with the table when you do this. Okay, so I'm going to get rid of this now. Okay, every member of the adult population visits population once per year. Okay, so in the first year, we'll get rid of yeah, I guess we can kind of sum up. So in the first year, 25,000 people are going to go to the doctors. In the second year, 25,500 people are going to go to the doctors. So this time we are summing, we're adding all of these up to find the total number of appointments from the beginning of 2012, so that's from here, till the end of 2019. Now this is where it gets more difficult. If I skip a few and we go to 2019, we don't want the beginning of it, we want the end of it. Now we don't have a way of saying it's the end of it. So instead of using the end of 2019, we're going to use the beginning of 2020, because the population at the end of 2019 will be the same as the population at the beginning of 2020. So which term is that I need? Well, term 1 was 2012, term 2 was 2013. Which term is 2020 going to be? Sorry, 2022. I think it's going to be term 11. Let me just double check this through quickly. Always double check your workings in these because they can be quite confusing. Yeah, definitely term 11. So we're trying to find the sum for 11 terms. So we're basically doing S11. So that's going to be my first term, 25,000. 1 minus 1.02 to the power 11 divided by 1 minus 1.02. So that's going to be the sum. Let's work all that out. Which gives me, I think this is right, 304,217. Probably should round up there. That's 0.88. And I think you guys should be to 2020. Oh, why have I done? Yeah, why have I done 2022? Well spotted, George. Sorry, let's do that again. Yeah, so I've read that completely wrong. What did it say? To 2019. Okay, 2019. End of 2019 is beginning of 2020. So it shouldn't be 11 there at all. It should be, I think there should be 9. Yeah, it should be 9. Okay, so I'm going to put 9 in my equation, and we'll do that again. Two, four, 3, 865.7, so 243,866. Cool, let's just have a look through your answers. Chloe, yeah, it's slightly out, you guys. As I said earlier, I think you've used the wrong end. And it's that link between your year and your term. Right, does that make sense to everybody why that's got to be the answer and why we're using 9 as a power based on my table? As with practice, these do become easy, but you need to do that table and you need to keep reminding yourself, what am I doing? What links to what? And the last bit, give a reason why this might not be appropriate. Well, there's a load of reasons. People die, more people might be born, people might not need to go to the doctors at all, people might need to go to the doctors more than once. So any of those answers you could say. I think, yeah, saying some people go to the doctors not often, some people go more than once a year. So it might not just be one person once a year. Cool, alright, we've got about 15 minutes left. Rather than start the new topic, I think let's do one more of these. So if you guys bear with me while I find one more modelling question. Cool, alright. Right, I'm gonna give you. Alright, I'm gonna give you guys till the end of the lectures to do this. We're gonna do it as a starter on Wednesday. But could you all try it now? I'm gonna sit right here, see if there's any comments. I might give you guys some hints. Give this a go now. Put comments, and then we'll start. I'll give you no time at the beginning of the next lecture. We'll just go bang straight into this, because I'm going to give you 11 minutes to do it now. So timer starts now, kind of. But I'll come back and talk you through any bits you get stuck on. Please comment if you're finding it difficult. I might give you some hints as well. Right, I didn't see any comments, so this one doesn't seem too bad. So be careful with this one. If you haven't finished it, guys, please can you try and finish it between now and Wednesday. I would like to see a photo of every single one of you having attempted this sometime between now and Wednesday. Also, make sure you got the skills checks done for last week. I'll be looking at those later, and any tests that you are overdue. Cool. Right, take it easy, guys, and I'll see you on Wednesday. Thank you. Also, rewatch this if you found this lecture difficult. I know some of you did. Watch it a couple times, and hopefully make a bit more sense of it.